Neptune, the farthest planet from the Sun, is now drawing attention from the scientific community in a statement hinting at potential signs of life.
More than 30 times farther from the Sun, almost at the edge of our solar system, there's one mysterious planet, Neptune.
There's a planet so distant in our solar system that its existence was once thought to be impossible for thousands of years. The notion of life existing there seemed even more far-fetched. This planet is none other than Neptune.
In 1989, NASA's Voyager 2 spacecraft whizzed past Neptune. 5 years later, we captured incredible images of this planet 4.3 billion kilometers away from Earth with the Hubble Space Telescope.
Neptune, which exists in the outer reaches of our solar system, has always been a source of fascination and mystery. Despite our advanced technology and countless studies, it continues to guard its secrets. But what if I told you that scientists now believe Neptune might be hiding something extraordinary, potentially even extraterrestrial life? Something that could change our understanding of life in the universe? Life on Neptune. Neptune is the 8th planet in our solar system and has been a source of mystery for thousands of years. Named after the Roman god of the sea, Neptune is a planet that holds many secrets beneath its cerulean atmosphere. Speaking of atmosphere, its winds are incredibly strong, reaching speeds of up to 1,500 miles per hour, making them the most powerful in the solar system. Despite the ferocity of these winds, some scientists are now wondering something impossible. Could life exist in such extreme conditions? Well, maybe. Why? Once again, this is where the atmosphere comes into play. Neptune's atmosphere is rich in methane. Methane is particularly interesting because on Earth, certain microbes known as methanogens produce methane as a byproduct of their metabolism. If similar organisms exist on Neptune, they might use the methane present in the atmosphere for their energy production, which means, as you guessed it, aliens might already exist there, and if they didn't already, chances are life might evolve there. Like I said before, Neptune is the farthest known planet from the Sun, orbiting at a distance of about 2.7 billion miles. It is 17 times more massive than Earth and almost 4 times wider, with a diameter of nearly 30,000 miles. Despite its size, Neptune has the 3rd smallest volume among the giant planets due to its thick atmosphere. Now let me ask you something. Do you know why Neptune is blue? In case you guessed that it is because of the methane, which absorbs red light and reflects blue, you'd be 100% right. But that's not all. You're probably familiar with the fact that Neptune orbits around the Sun. But did you know that it takes about 165 Earth years to complete one orbit? That's right. Then, there's something that fascinated every single one of us: Neptune's formation and evolution. Over 4.5 billion years ago, our solar system was a chaotic swirl of gas and dust. In a big, spinning disk of material around a young, hot sun, tiny particles began bumping into each other and sticking together, forming clumps. These clumps grew bigger and bigger, eventually becoming the building blocks of planets called planetesimals. This is where Neptune's story begins. Neptune emerged from the same process that formed the rest of our solar system. But even then, its formation was a lot different compared to Jupiter and Saturn. While Jupiter and Saturn gained most of their mass from nearby gas, Neptune formed further out in the colder parts of the solar system, where there was a lot of icy material. This is why Neptune is known as an ice giant. As Neptune grew, it started to clear its path, pulling in more material and getting bigger. However, its formation wasn't straightforward. Neptune likely did not form where it is today. It moved inward from its original spot, getting closer to the Sun as it grew. Scientists believe Neptune might have started even farther out, beyond Pluto, and slowly moved to its current position. The reason Neptune ended up so far from the Sun lies in the gravitational forces in the early solar system. Neptune's movement was likely influenced by the gravity of the other giant planets and the mass of the surrounding gas and dust. As Neptune moved inward, it interacted with other planets and leftover material, finally settling into its current position. Neptune and ancient astronomy. Neptune has formed and evolved, but how did the world come to know about it? Centuries ago, people didn't know Neptune existed. Ancient astronomers gazed at the night sky but had no idea Neptune was out there. It wasn't until the 19th century that we discovered its existence. The story begins with the planet Uranus. Scientists noticed that Uranus wasn't moving as expected. Its orbit was slightly off, indicating that something was exerting a gravitational pull on it. This mystery called for a combination of math and astronomy. In 1846, a German astronomer named Johann Gottfried Gall used the calculations of a mathematician named Urbain Le Verrier to locate Neptune with a telescope. Surprisingly, they found the planet exactly where the math predicted it would be. This was a huge victory for science, and even maths, because it revealed that mathematical predictions could lead to the discovery of new planets and enhance our understanding of the solar system. It opened up new fields of study and expanded our knowledge of celestial bodies. But guess what? The history goes way back. Even ancient civilizations like the Babylonians, Greeks, and Romans had star maps and records of the sky. They were the experts, but the problem is, they observed Neptune, but mistook it for a star. Still, their work led us to where we are, not just in our understanding of Neptune, but of the entire universe. NASA's attempt at reaching Neptune. Curiosity and scientific skills have always gone hand in hand when it comes to making discoveries in space.
Scientists to explore alternative and more captivating theories.
And NASA's efforts to reach Neptune were a perfect blend of both. Even though Neptune is incredibly far away, NASA has been working hard to explore it. One of the most famous missions was the Voyager 2 spacecraft. Launched in 1977, Voyager 2 was sent to study the outer planets of our solar system. Its path was carefully planned so it would pass by Neptune and collect data. And this plan was successful. Voyager 2 flew by Neptune in 1989, which was truly a historic event. The Jet Propulsion Laboratory managed these missions, and the Neptune mission was called the Voyager Neptune Interstellar Mission. Voyager 2 began taking navigation images of Neptune in May 1988 and officially reached the Neptune system on August 25, 1989. On that date, Voyager 2 made its closest approach, flying just 4,950 kilometers above Neptune's North Pole. Initially, Voyager 2 planned to fly close to Neptune and Triton, but had to adjust its path to avoid ring material. Despite this, it showed us quite some amazing details about Neptune's atmosphere and weather. The bright blue color, the great dark spot, and the ring system were all captured in stunning images. Voyager 2 also provided the first accurate measurement of Neptune's mass, found that Neptune's magnetic field is highly tilted, and discovered weak auroras. It also confirmed that Neptune's rings are complete and counted as 4 rings. This mission was a huge success, and this mission was no joke because reaching Neptune is tough because it's so far away and has a harsh environment. But Voyager 2's success showed that with clever planning and hard work, nothing is beyond reach. NASA has more plans for Neptune in the future. They want to send new spacecraft to explore Neptune and its moons. Although there are no confirmed future NASA missions to visit the Neptunian system in 2024, there is a tentative Chinese mission planned for launch in 2024. Let's see where these plans lead us to. Harsh environmental conditions. Neptune's environment is harsh and extreme, as one might expect from a planet so far from the Sun. It's far from what we usually think of as livable. First, there's the cold. Neptune is one of the coldest places in the solar system, with temperatures dropping to around -373 degrees Fahrenheit. Being the farthest planet from the Sun, it doesn't get much warmth, which makes sense given its distance. Neptune does not have a solid surface. Instead, it features a thick atmosphere that transitions into a hot, dense fluid of icy materials, including water, ammonia, and methane, above a rocky core.
Calm and breathtaking as it may appear on the surface, Neptune is a dangerous and violent place.
The temperatures at the planet's core are estimated to be around 5,400 Kelvin, which is 5,100 degrees Celsius, significantly hotter than its outer atmosphere. Neptune's atmosphere is dense and stormy, composed mainly of hydrogen, helium, and methane. These gases create thick clouds that envelop the planet, leading to extreme weather and powerful winds. One of the intriguing aspects of Neptune's atmosphere is its layered structure. The upper atmosphere contains icy clouds of methane, while deeper layers harbor clouds of ammonia and hydrogen sulfide. These cloud layers contribute to the planet's dynamic and ever-changing weather patterns. Neptune's high-pressure environment is another critical factor. Inside the planet, there's a slushy mix of water, ammonia, and methane, creating pressures more than 7 million times that of Earth's surface. Some scientists believe this extreme pressure could potentially support unique forms of life. In addition to hydrogen, helium, and methane, Neptune's atmosphere also contains trace amounts of ethane and acetylene. These hydrocarbons form through chemical reactions induced by ultraviolet sunlight and charged particles from the solar wind interacting with methane. Neptune also experiences auroras, although they are much weaker than those on Earth. These auroras are caused by the planet's magnetic field interacting with the solar wind. Additionally, Neptune has smaller storm systems known as vortices, visible in its atmosphere. These vortices are large-scale, high-pressure systems similar to extreme winds on Earth. Triton, Neptune's icy moon, rings, riddles, and the quest for life. Being the biggest of Neptune's 16 moons, Triton has some really unique characteristics, but scientists are particularly interested in Triton because of the possibilities it presents. The combination of an icy surface, potential underground ocean, and geological activity makes Triton a prime candidate in the search for extraterrestrial life. Instead of lava, Triton's surface has icy slush eruptions. It also has rings made of dust and ice particles, though they aren't as dramatic as Saturn's. These rings hint at possible geological activity beneath the surface. One of the most interesting things about Triton is the idea that there might be an ocean hidden beneath its frozen crust. Scientists think this ocean could be a place where extraterrestrial life might exist. If life can thrive in the dark, high-pressure environments of Earth's deep oceans, why not in Triton's hidden ocean? This isn't just wild speculation. The warmth from this underground ocean combined with the icy surface might create an environment where life could exist. If we could drill through Triton's thick ice, who knows what tiny life forms we might find. Other moons. Triton often steals the spotlight, but Neptune has other intriguing moons worth talking about. One of these is Nereid, Neptune's third largest moon. It's known for its highly eccentric orbit, which is quite unusual and suggests a bit of a troublesome past. Why? Well, Nereid might have been captured by Neptune's gravity. This means that this moon did not form an orbit around Neptune, but rather originated elsewhere in the solar system and was later gravitationally pulled into Neptune's orbit. Proteus is another interesting moon, discovered by Voyager 2 in 1989. Despite being one of the larger moons, Proteus is very dark and reflects little sunlight. Its surface is heavily cratered, showing that it has been hit many times over the years. Then there's Larissa. This moon orbits close to Neptune and has an irregular shape suggesting it doesn't have enough gravity to become round. Larissa's surface is covered in craters, so that means there's quite a bit of history of collisions with space debris. Despina and Galatea are two more moons that deserve attention. They orbit just outside Neptune's rings and help maintain the structure of those rings. Despina, like many of Neptune's moons, is irregular in shape and covered in craters. Galatea, on the other hand, plays a key role in shaping the ring system, acting almost like a shepherd moon. Thalassa and Naiad are two smaller inner moons. These tiny moons orbit very close to Neptune and to each other. Their orbits are so precisely tuned that they never collide, passing each other at just the right moments in what's called a resonant relationship. And Neptune's gravity might just play a major role in this: the impact of Neptune's gravity on the solar system. Neptune might be one of the most mysterious planets in our solar system, but its gravity has a big impact beyond just space. It helps shape the Kuiper belt and influences comets and asteroids, which could be connected to the possibility of life on Neptune. First, let's talk about the Kuiper belt. This icy region is full of small bodies and dwarf planets far from the Sun. Neptune's gravity shapes the orbits of these objects, creating gaps where its pull is strongest. This might seem unrelated to life, but these icy bodies could have organic compounds or materials needed for life. Now let's move on to Triton, Neptune's largest moon. Triton is really interesting to scientists because it orbits Neptune in the opposite direction of the planet's spin. This backward orbit is due to Neptune's strong gravity. Triton also experiences intense tidal forces that generate heat. This heat could keep subsurface oceans warm, potentially creating an environment beneath its icy crust where life could exist. Scientists believe these environments might harbor life, similar to some icy moons in our solar system. Another surprising thing about Neptune's gravity is its role in keeping the outer planets stable. This stability makes sure that the orbits of Neptune and its moons stay steady, which is quite important for any potential life-supporting conditions. If Neptune's gravity changed, it could disrupt the balance needed for life. But as it is, Neptune's gravity helps maintain a consistent, stable orbit for the planet and its moons. The mysteries. Neptune is a planet full of mysteries that continue to puzzle scientists. Although it is the farthest planet in our solar system and might not seem to offer much, there is an entire world of secrets we are only beginning to uncover. One of the biggest puzzles is the strange heat emission. Despite being so far from the Sun, Neptune radiates 3 times more heat than it receives. This is baffling to scientists who think that internal processes in the planet's core or atmosphere might be creating this extra heat. This heat could be driving Neptune's wild weather and affecting its atmosphere. Then there's the Great Dark Spot. This massive storm, similar to Jupiter's Great Red Spot, is about the size of Earth. It was seen by the Voyager 2 spacecraft, which captured images of this storm in Neptune's southern hemisphere. The Great Dark Spot is a testament to Neptune's stormy weather and can move up and down in the atmosphere. The edges of this storm have winds blowing up to 1,300 miles per hour, the fastest recorded in the solar system. Scientists think the Great Dark Spot might be a hole in Neptune's methane cloud layer. Over time, this spot has changed in size and shape. Surrounding the Great Dark Spot are bright white clouds, similar to high-altitude cirrus clouds on Earth. However, these clouds are made of frozen methane and float 30 to 60 miles above the main cloud layer. Unlike Earth's clouds, which come and go quickly, Neptune's clouds around the Great Dark Spot stayed for at least 36 hours, or 2 Neptune days. Neptune's dark spots are thought to form in the troposphere, below the bright cloud tops, and can last for several months. Scientists believe they are vortex structures, and if that wasn't interesting enough, there's also the idea of diamond rain on Neptune. For nearly 40 years, astronomers and physicists have suspected that the high pressure and temperature inside Neptune could turn carbon into diamonds. These diamond particles might fall like rain through the atmosphere. Although we haven't seen it directly and it remains a hypothesis, it's a pretty wild and fascinating idea, current and upcoming missions. So it's no surprise that scientists are eager to learn more about Neptune and other planets. With new technology and techniques, many upcoming missions aim to revisit this icy giant. NASA is considering new spacecraft designs and mission ideas that could give us fresh insights into Neptune's atmosphere, magnetic field, and moons. These missions will build on the work of Voyager 2 and explore areas we haven't seen before. Right now, advanced telescopes like the Hubble Space Telescope and the James Webb Space Telescope are helping us study Neptune from afar. Even though there aren't any approved future missions to Neptune yet, many interesting ideas have been proposed. One proposal is the Interstellar Express, a Chinese mission that plans to fly by Neptune in 2038 to explore the heliosphere. Another exciting idea is Odinus, a twin spacecraft mission to Neptune and Uranus proposed for 2034. There's also the OSS mission, a collaborative effort between ESA and NASA to map deep space gravitational fields. And it doesn't stop there. There's the Triton hopper, which aims to land and hop around on Triton, and Trident, a flyby mission to study Triton. Neptune Odyssey is another proposed mission that plans to send a probe to Neptune in 2033, arriving in 2049. There's also the Triton Ocean World Surveyor, a less capable version of Neptune Odyssey, set to launch in 2031 and arrive in 2047. The next optimal launch window for a Neptune mission using Jupiter for a gravity assist is in 2031. But with new Space Launch System technology, it might be possible to launch deep space missions without needing a gravity assist, offering more flexibility. Other planets that might be habitable. Believe it or not, Neptune isn't the only planet that might be habitable. Scientists have discovered many habitable exoplanets. Exoplanets are planets that orbit stars other than our Sun. Think of them as cousins to the planets in our solar system, but they circle different stars out there in space. Before the 1990s, we had never seen a planet outside our solar system. It wasn't until then that we confirmed exoplanets actually exist. Since then, NASA's list of these distant planets has grown a lot. As of 2023, there are over 5,500 confirmed exoplanets and almost 10,000 more that might be planets. Scientists are particularly interested in exoplanets that are in the habitable zone. This is the area around a star where it's just right, neither too hot nor too cold, for liquid water to exist. Finding exoplanets in this zone could be a big clue in the search for life beyond Earth. Life on exoplanets is possible, but it depends on the exoplanet. Life is more likely to be found on an exoplanet if it's in the habitable zone of its star. This is the right spot where it's not too hot or too cold, which could allow for liquid water, something life needs. There's also a new idea about Haitian worlds. These are planets with huge oceans covering them. They might have liquid water even if they're not in the usual habitable zone. This means there could be more places around a star where life might exist. So, how many planets could have life? The Drake equation helps us guess how many planets might have intelligent life, but it doesn't give a definite answer because it's based on a lot of guesses. To find planets that might have life, we look for certain things: liquid water, energy, and nutrients. Life needs water to dissolve and move chemicals for important reactions, energy from sunlight or chemical reactions, and nutrients to grow and survive. Planets with water cycles, good atmospheres, can provide these nutrients. Scientists now believe there are about 60 billion planets in our galaxy, the Milky Way, that could have the right conditions for life. These planets are in the habitable zone, where it's warm enough for liquid water. And remember, our galaxy is just one of billions in the universe. each with many stars and potential planets. Some researchers think there could be around 50 sextillion planets that might support life in the entire universe. So, while we can't say exactly how many planets could have life, it's exciting to think there could be many. And there we have NASA, whose big goal is to find clear signs of life on planets beyond Earth. How soon we can do this depends on two things: how common life is in the galaxy and how lucky we get in our search. Some notable exoplanets include Proxima Centauri b, which orbits the closest star to our solar system and is located just 4.24 light-years away. Final thoughts. Not just scientists, everyone is thoroughly excited about the idea that life could exist in extreme conditions. This possibility makes us rethink what makes a place habitable and opens up new questions to explore. Thankfully, Voyager 2's trip to Neptune gave us a first look at this icy planet that solved a lot of mysteries and give us a better understanding of this far, far world. But one thing is for sure. Neptune's story is one of discovery, wonder, and limitless possibilities. There's still a whole lot of world that is still hidden, and we know nothing about it. But as long as humans are determinate and there are technological advancements, we can go beyond, way beyond our imagination. What do you think about Neptune and the possibility of life there? Let us know in the comments below. And if you want to hear more such jaw-dropping facts about the wonders of the universe, don't forget to subscribe. Until next time.